2015 Paper 1 Question 5 Differentiation. So in A we just had a standard algebra question where we were asked to solve the equation. So when we're asked to solve our equation, that means we want to find our values for x, but we have to be careful here because it has a surd in it. So therefore when solving our surd equations we always have to remember to check our answers. Same when we're solving our log equations. So to solve our surd equations, what we want to do is get rid of the surd. So to do that, we're going to square both sides. So we have to be careful that we make sure that we're actually doing that to both sides, not just to the one with the square root in it. Okay, so always keeping your equations balanced. So if I square the left, I just simply get x squared. And if I square the right, well, I'm squaring a square root, so I'm left with what's underneath the square root. So now I want to bring everything to one side. So if I'm bringing all the terms to the left-hand side, I'm subtracting x and subtracting 6 from both sides, which gives me 0 on the right-hand side then. So I have a nice simple quadratic here to solve. So again, what's multiplying to give us minus 6 and adding to give us minus 1? Well, it must be minus 3 and 2. And of course, you can use your minus b formula if you want to solve your quadratic equations. But of course, I always prefer to do it this way. So we have, take out your first two terms, take out the highest common factor. So the highest common factor between the first two terms is x, leaving me with x minus 3. And the highest common factor between the second two terms is 2, again leaving me with x minus 3. And we know we've done something wrong if these two brackets aren't the same, because of course we want to take that out as our second highest common factor. So by taking out x minus 3, I'm left with x plus 2 and equals 0. So if both of those factors multiply to give 0, that means that one of them or both of them must be equal to 0. So therefore that gives me x equals 3 or x equals minus 2. So now, really important, we have to check our answers. Okay, so we need to check or test these two values by subbing them back into the original equation. So if I'm checking x equals 3 first of all, then that means I have 3 is equal to the square root of 3 plus 6. So in other words, wherever there's an x, I'm putting 3. So the left-hand side should equal the right-hand side. And of course, the square root of 9 is 3. So that is true. So that means x equals 3 is one of my valid answers. And then if I check x equals minus 2, we want to again see, does the left-hand side equal the right-hand side? So we have minus 2 is equal to the square root of minus 2 plus 6. So minus 2 is equal to the square root of 4. So again, if I get the square root of 4, my absolute value of my square root of 4 is 2. So therefore this is not true, and therefore I must discard the value that x equals minus 2 as my answer. So again, we have 10 marks going for this, and it's a 10C question, so it's broken down into 3 parts. So we're getting a 0, a 4, an 8, or a 10. So in part B, we're asked to then differentiate x minus root x plus 6 with respect to x. So basically what we're saying here is that y is equal to x minus root x plus 6. I can't differentiate that as it stands, so I always have to have it as x to a power. So therefore root x is x plus 6 to the power of a half. So once I have every term as x to a power, I can then differentiate using the general rule, where I bring down the power and take 1 away from the power. So in other words, if I differentiate x, I just get 1. And if I differentiate minus x plus 6 to the power of a half, well, I'm using the chain rule here, so bring down the power, take 1 away from the power, and now multiply by the derivative of what's inside the brackets there. So always, it's a function within the function here. So multiply by the derivative of the function within the function. So that is my answer. I'm just going to tidy it up. So that's my first derivative. So that's basically 1 minus, and it's a half times x plus 6 to the power of minus a half. So minus always means 1 over. And it's 1 over x plus 6 to the power of a half, which is the square root of x plus 6. And then if I multiply all of that by a half, well, that just gives me 2 on the bottom. Okay, so therefore that is my derivative. Now you can, of course, get your lowest common denominator there and simplify that too. So it's 5 marks going for that. So it's only a 5b question, so 0, 2 or 5. So that could also be written as dy dx is equal to 2 root x plus 6 minus 1 over 2 root x plus 6 if I get my lowest common denominator. So both answers are acceptable. So the next part of the question then, we're asked to find the coordinates, so that means our x and our y value. So always important there that we're not just finding the x value, we have to find the y value too. And we have to find the coordinates of the turning point of the function, where x has to be greater than or equal to minus 6. And the reason x has to be greater than or equal to minus 6 here is because if we put in a minus 6 there, I get minus 6 plus 6, which is 0. So of course, the number has to be bigger than minus 6, because if it's less than minus 6, I end up with, say, minus 7 plus 6, which of course is the square root of minus 1, which isn't possible. So anything greater, anything less than minus 6, I should say, gives us a negative number. So that's why we're told that little piece of information there. So what are we doing to find the turning point? Well, we're looking for our max or our min. So our local max or min is found by letting dy dx equal 0. So I've already found dy dx from b. So all I need to do is let dy dx equal 0 to find my turning point. So my dy dx is 1 minus 1 over 2 root x plus 6. And I'm going to let that equal 0. So I'm going to multiply across by the lowest common denominator there, which is 2 root x plus 6. So 1 times 2 root x plus 6 is just 2 root x plus 6. And 1 over 2 root x plus 6 times 2 root x plus 6 is just going to be minus 1. And then 0 times 2 root x plus 6 is, of course, 0, because 0 times anything is 0. So bringing everything to one side there, then I have 2 root x plus 6 is equal to 1. So root x plus 6 is equal to a half. I need to get rid of that square root sign, so I'm going to square both sides. And if I square both sides, I get x plus 6 is equal to a quarter. And then if I bring over the 6, I get a quarter minus 6, which is minus 23 over 4. So therefore, that's my x coordinate. So to find my y coordinate, I'm going to sub x back into the original function. So in other words, sub x into my function y. So y, if I just go back up there, was x minus root x plus 6. So if I sub my value in, that's going to be minus 23 over 4 minus the square root of minus 23 over 4 plus 6. So if I put that into my calculator, I end up with y is equal to minus 25 over 4. And it doesn't say find the local max or the local min, so I'm not being asked to specify whether it's a max or a min here, so I don't need to do the second derivative test. I was just asked to find the coordinates of the turning point. So I simply say my turning point is equal to minus 23 over 4 minus 25 over 4. And there was 10 marks going for that, and it's broken down into 3 parts, so a 10C question. So we had 0, 4, 8, or 10.